Okay, here's our continuation of section 8.3. This is part 2. The next thing we're going to talk about in this section is what we call continuous compound interest. So we just discussed compound interest, calculated different amounts of times each year, biannually, semi-annually, quarterly, monthly, daily even. But this continuous compound interest is where interest is compounded all the time. It increases indefinitely, right? So interest is calculated all the time on the money that you have in your account. So we already discussed the compound interest if you have a certain number of times a year. But now we have another formula for continuous compound interest that you're getting all the time, okay? Where P is still our principal amount, R is still our interest rate, T is time in years, and E is just that exponential number that we're going to use, kind of like pi is, right? 3.14. Well, E is 2.71. This helps us calculate continuous compound interest. Find it on your formula sheet. Make sure you're comfortable with where it's at and how to use it. Let's do some examples using it. Example number 3 says you decide to invest $8,000 for 6 years, and you have a choice between 2 accounts. The first account pays you 7% per year, compounded monthly. The second pays you 6.85% per year, but it's compounded continuously. Which one do you think is the better investment? So now we have 2 choices. We can go to bank A, we can go to bank B, and really we want to get the most money out of our account. So we've got to figure out which bank is going to be the best. We have $8,000. We're going to leave it in the account for 6 years. We've got to decide, is 7% compounded monthly better than 6.85 but compounded continuously? Guess which one you think is going to be better. But now let's actually do some work to figure out which one we think is going to be better. So let's make a little chart here. Let's do our 7% compounded monthly versus, let's do pink. Well, I already have pink. Let's do orange. Versus our 6.85% but compounded continuously. Okay, 2 different ideas, 2 different formulas we have to use. Let's set them up separately, and then let's actually do the calculation to see which bank we should choose. Why don't you pause the video, set up both formulas, one for the 7% compounded monthly using the compound monthly formula, number 1, and then set up the one for 6.85% compounded continuously using our new formula. I want you to set it up by yourself to make sure that you know how to use the formulas right, and then we'll continue on to make sure we can calculate the right amount. So here we go. Okay, so hopefully your formulas look like mine. And so now all we have to do now is put it in our calculator, making sure that we do it the correct way so that we can figure out which one of these options is going to give us the most money. So I, again, suggest that you pause the video, put them both in your calculator, make sure you know how to use your calculator properly to get the correct answer, and then double check that your answer matches mine. So I'm going to do that. You do it first, double check it with mine, and let's see if we get the same answer. Raised to the, I'm going to do 72nd times 8,000. I got 12,160 and 84 cents. I'm going to write that down. Did you get the same number as me? $12,160.84 if I put it in the account that has 7% interest compounded monthly. Only 12 times a year versus continuous, but the interest rate is a little bit higher. So let's see. Let's go ahead and do the other one. I'm going to clear out. Okay, so I have 8,000 times, and then I have to find my E button. My E button is under my LN button. If you look on my screen, it's the very right column, third button down, but it's the second option. It's the one underneath. So I'm going to go on my calculator, Shift E, raise to the, and then I'm going to use parentheses, 0.0685 times 6 in parentheses. So my calculator knows to raise the whole entire thing to that power. So make sure you find your E button, and then when you raise it to the exponent, put parentheses around it so your calculator knows that those are all kind of combined, okay? Or you're going to have to do it off to the side and then make sure you put that whole long decimal, but I'm not sure if you're going to be able to do it accurately, so you might want to use the parentheses just like I did on mine. So you should end up getting $12,066.60. So let's compare that to the other one and see which one would be the best option. So $12,066.60. So which one would get us more money? Oh, so it looks like the Bank A that has the 7%, even if it's only compounded monthly, because it's 7%, it looks like that's going to give us more money than a 6.85, but that's compounded continuously. I maybe thought that the continuous one would have been better, but maybe because the interest rate is a little bit higher, that's how you're getting more money. Okay, so point is, make sure that you know how to use the different formulas and when to use those different formulas and how to put it in your calculator the correct way. Okay, let's do one more in this video and talk about using that formula but backwards. Okay, so here's another formula we have to talk about future value and present value if we already know the future value. So kind of like how we did it in one of the previous sections where we know the ending amount now and we want to figure out the principal amount. Okay, so again, this is for our compound interest when it's paid different amounts of times each year. You have it on your formula sheet. Let's do an example so we know how to use this formula. Example number 4 says, how much money should you deposit in an account today that earns 6% compound monthly so that you accumulate $20,000 in 5 years? So I know I have 6%. I know that it's compound interest, not simple interest. I know that it's compounded monthly, not continuously, and I'm doing it for 5 years, okay? So I know that I have a future value. I already know how much money I want to end up with. That's the $20,000. I need to figure out how much money to put in my account. Now you could actually do this a couple different ways. You can start with our older formula that we had for compound interest. You can plug in your information. So I know that I have $20,000 in the end. I don't know how much I want to put in now. I know that the interest rate is 6%, so 0.06. I know that it's compounded monthly. How many times a year is that? 12. So I'm going to put the 12s up there. And I'm going to leave it in the account for 5 years. So I can use that formula and then just solve it backwards. Or if I'm trying to solve for P, do you notice that this whole piece is right next to the P, the principal amount, which means multiply? So in order to get P by itself, wouldn't I then have to divide? So that's what we're going to do. We're going to find that P by taking the 20,000 and dividing it by that big old chunk over there, which really is this formula. So it's kind of already set up for you to solve, but you can do it either way. So we should be able to find the P by taking our ending amount, our future value, which was the $20,000, and then plugging in our interest rate, plugging in how many times a year it's compounded, and for how many years. You notice that they're the same exact formula, just one's already kind of solved for you. So whatever one you prefer, you should still get the same answer. All right, here's the tricky part. We got to put it in the calculator the right way. Here we go. So we have 20,000, 1, 2, 3, divided by, now here's the part you have to use parentheses, 1 plus 0.06 divided by 12, parentheses, and that's raised to the 60th power. You should end up getting $14,827 and some change, right? 4439, let's write it down. So I have $14,827, 4439, and then it kept going, didn't it? Okay, so make sure you put it in the calculator the correct way. Make sure you have the same number as I do, but now we've got to think about our answer. This was one of the ones where we're working it backwards, remember? where I want to make sure that I put enough money in my account now so I can have at least $20,000 in those 5 years. So if I were to normally round it, I would stop and say 44 cents. But because there's this extra stuff back here, if I cut it off too early and cut it off at 44, and I put it in the account for 5 years, I might not have enough. I might not have exactly $20,000. I might be a penny short. And if I'm a penny short, then I really don't have $20,000. So this is one of the examples that we have to round up when we normally want it to make sure that we actually have enough money in the end. So your final answer on this one should be $14,827.45. You need to make sure that you put in 45 cents, $14,827.45 now, in order to make sure that you're going to have $20,000 in 5 years. Okay, make sure that you practice all those different formulas, punching it in your calculator the right way, and make sure you remember when to round